right, so we're talking about f of x is 1 minus x to the what power? Negative 1. Excellent. What's the first derivative? Negative 1 times 1 minus x to the negative 2. Oh, and then what happens? What kicks out here? Chain rule kicks out a negative 1, right? So what does it simplify to? 1 minus x to the what? Negative 2, everybody. The negatives cancel. You with me so far, everybody? So what's the second derivative come out to be? Negative 2 times 1 minus x to the negative 3. So what do you also kick out? Negative 1. So what do you end up with? 2 times 1 minus x to the... So then you keep on doing this, and eventually what do you theoretically see? Negative 3 times 2 times 1 minus x to the negative 4 times negative 1. So what does that turn into? 3 times 2 times, I'll put in the 1 there just for added effect, to the negative 4. Do you see a pattern developing, everybody? So what is, if I do this, what is fn? What is the nth one going to be of x right here? N factorial 1 minus x to the what?
Negative n minus 1.
Or just negative n plus 1. Either way, it's the same thing, right? Do you agree with me, everybody? Do you agree? Okay. So f of 0. What's f of 0 going to be? 1. What's f prime of 0 going to be? 1. Do we agree? Is it 1 and 1? Is f prime of 0 1?
Yeah.
Yeah. What's f double prime of 0? 2. What's f triple prime of 0? Not 2 factorial, 3 factorial. So what can you do to these right here? And what could you turn the first one into? 0 factorial. So you're going to go down to here. What's this one? What's fn evaluated at 0 going to be? N factorial. So what was that Cn term thing? Do you remember from yesterday? The general term? What was each term going to be equal to? Fn evaluated at 0 over what? Times what? X to the power of n, right? Correct?
Yes.
So what happens when you start pairing all these up and plugging them in? What starts canceling? The what? The factorial starts where each term comes from. What's the next one going to be? 1 factorial over what? Times what? X to the 1. What's the next one going to be? 2 factorial over 2 factorial times x to the 2. And then if you wanted it to the third power, you keep on going, and then you end up with 3 factorial over 3 factorial x to the third. So does this simplify? Yeah, what's the first term simplify to? What? So 1 plus x squared plus x to the what? Cube. So here's the thing. In this case, do you see all of these coming out to be n factorial? Is that always going to be the case?
No.
No. When we did the derivative and canceled everything nicely, these came out really, really freaking nice. These are really, really, this is as nice as it gets. Here's something you just have to remember. What was this? So if we keep on going, it keeps, like, what's the fifth one going to be? You just add in 2 more, right? So it goes 1, 2, 3, 4, 5, right? Another way to see this, everybody, if you want to believe in this a little bit more, would be this. We just effectively showed that you might believe this already, maybe you might believe this. We just showed that 1 over x, sorry, not 1 over x, 1 over 1, it's 1 minus x, right?
Yes.
We just showed that that's equal to what? 1 plus x plus onto infinity, right? How can you logically, what's a piece of math you could do to that to believe that a little bit more? What could you do to that to believe that a little more? What? No, you could do an algebra 1 technique. If you have 2 fractions that are equal to one another, what can you do?
Minus?
Cross multiply. So let's just say I did this, everybody. If I did this, what happens if you cross multiply this thing? Well, you get 1 times everything, right? And then you have negative x times everything. What ends up canceling? Everything except for 1. 1 equals 1, it's true. So if you cross multiply this, it's a true statement. Now, is this true for all values of x? Is this statement true for all values of x? Is the radius of conversion infinite?
Yeah.
Really? Look at it. It's a geometric series with the ratio being x, right? Geometric series don't all converge, do they? No. Where does this converge? What values of x does this work for? X is between 1 and what? What?
Is it negative 1 and
These are 1 or negative 1?
Negative 1 and 1. Negative 1 and 1? The radius of the ratio. How would you test to see what the radius? Oh, you would use the ratio test. But the point is, if you plug in like a billion into this, 1 plus a billion squared plus a billion, that diverges, right? But 1 over 1 minus a billion is finite. Okay, moving on. You want to do number 7? You guys, I think that's the arctan one. Oh, yay. I love arctan. What, you don't like arctan?
The derivative of this.
Oh, you guys just don't remember your AB calculus? You don't? So we're doing the same thing for arctan of x.
what number is that?
It's number 7, right? It's on your own. Keep on take the next 3 derivatives for me. You have to go to the 4th derivative. Go to the 4th derivative.